So this is Hephaestus' Revenge. It is a roguelike dungeon crawler, and the objective of the game is to go through the randomly generated map level by level, following a set path. And you follow the path all the way up to the final boss, and once you defeat the final boss, you win the game. So we start off at the main menu where there are three buttons. There's the start game button, tutorial, and quick game. So for tutorial, a panel will appear to teach the players how to play through the game, and there's like a back and next button to go through the different pages. So for example, attacking, the tutorial for defending, enhancing your attacks and defense, random events, and explaining the rest sides. And once you finish reading the tutorial, you can press the close button and you'll exit out. And then next is the start game. It will immediately generate a map and it will launch into the map. So from here, the players are presented a map where they can scroll up and down to look through the map. So the black lines are the path that the players can take, and the icons are the encounters that they will face in that area. So to start off the game, you'll see the flashing, pulsating icon that is like bolded. When you click into the icon, the encounter will start. So a skull icon would represent an enemy fight. So you click into it, and it will launch immediately straight into the battle. So this is the battle screen. From here you can see the player's health. Right here you can see the player's energy. You can see the intention of the enemy and their health, and at the bottom you'll see the attack button, the defend button, and the various materials that you have, and your end turn button. So for the players to attack, they will have to drag and drop to the target that they want. An arrow will appear to indicate which target they have selected. Whatever target their mouse is hovering over, there will be a highlight to indicate that is the target that you have selected. And players will just let go of their mouse and the attack will play out. So next is the defend button. The players will just have to press down their mouse and the animation will play, and the health will be surrounded by a blue outline, and right beside the blue outline will be the amount of shield that they currently have. The amount of shield will block the damage that the enemies are dealing. So next is enhancing attacks and defense. Players use materials to enhance their attacks and defense. As you can see here, these are the materials that the player has with the icon and the amount of that materials that they have. So for example, you just select this crystal icon, you drag and drop into the actions that you want to enhance, and you let go, and it will automatically enhance the attack that you want to do. You can also enhance your defense. You just do the same thing, drag and drop into defense, and it will increase your amount of defense that you have. So each of the actions costs 1 energy to play out, and after you finish your energy, you can end turn to proceed on to the enemy's turn, which is done by this button right here. And you click it and the enemy will play out their actions, and the turn starts again when you roll the dice for the materials. So that is just the general idea of the combat in this game. So once you defeat the enemy, the map will reappear again and you can proceed on to the next location, which is the pulsating icon. So in the game there are multiple different enemies, and each enemy has their own attacks and their own defense. As you can see right now, it's a wisp, and previously it was a slime enemy. Another encounter that players can face are random events. Random events are denoted by a question mark, and once the player clicks into it, a panel will appear and it will explain the event that is happening. And the players are presented two choices. They could participate in the event and they might get a reward out of it, or they can leave and no harm will be done to them. So this is an example of a different random event. This is just a free upgrade and players could just open a chest. And yeah, feeling more sturdy means that the players get extra defenses. So the last random event that can occur is spin the wheel, where the players are presented the option to spin or leave, and when they spin the wheel, a wheel will appear, and whatever thing they land on is what they got. So I got a heal here. Another encounter that players can have are rest sites. Rest sites are denoted by the campfire symbol, and when the player click into it, they are presented with three choices. They could rest to recover HP. They could upgrade their attack, which will increase the amount of damage they deal, or upgrade their defense, which will increase the amount of shield they get. There are mini bosses generated around the map, which are denoted by this skull icon with the horns. Uh, these mini bosses are a stronger variant of the enemies that you face. So, example, here you'll be fighting a three-headed dog, and as you can see, the dog has way higher amount of HP, and the damage that they deal are way higher. So now we have reached the boss, and the boss is a giant slime, and it's a very difficult fight for the players. So I'll try to defeat the boss right now. So unfortunately, I couldn't defeat the boss. But yep. So I lost all my HP, and now I've been shown the death screen. From here, the player can click play again, which will restart, regenerate a new map, and the player can go through the map again, or they can go back to the main menu. So now I have enough damage to defeat the boss, and I'll do it. So once you defeat the boss, it will bring you to the victory screen, and the same thing happens as the death screen, where you're presented a play again and return to menu button. And you can click either, so you can click play again, and it will generate a brand new map with different encounters, so the experience is new to the player. So this is the random seed generator. It has the method generate seed. It takes in the current system ticks and initiates the random class that Unity has with this seed. It also has the method set seed to set whatever seed that the player wants, and the method display seed to show right here the current seed that this gameplay is on. So this is the probability manager class. It has one static method in it, which is select weighted item. This method takes in a dictionary, which has a type for its key and a float for its value. The float is the amount of weight this item has, and the higher the value of the float, the more likely this item is going to be selected. Firstly, it has two variables. There's a float for total weight, and there's a boolean if the item is acquired or not. And firstly, it goes through the entire dictionary to add up all the weight of every item. So next is a while loop, and the condition is if it has acquired an item or not. So within the while loop, it will go through a for loop to go through the dictionary, and each iteration of the for loop will generate a random value from 0 to the total weight, and it also has the weight of the current item that this iteration is in. Then next, to check if the item has been selected, uh, it goes through a if statement where if the random value falls below the current weight of the item of this current item in this iteration, it will return this current item as as the item that is being selected. So just in case something happens, I have a return default which will return now uh, to show that something went wrong with this code. So I generated the map using the concept of graph, and the graph is made out of two components, and it's the nodes and the edges. The edges are the path where the players can take, and the nodes are the encounters that the players can face. So specifically for my map, I used a directed acyclic graph, which is a graph where the edges have a direction. So for example, uh, from this node, this path can only go in this direction up to this node, and same goes for any other subsequent path. So from here you can only go to this node, and from here you can only go to up to these two nodes. So for this graph, I decided to use the adjacency list to represent the path between each nodes. So for example, in the adjacency list, it will contain uh, the initial node and the targeted node that it can go to. So in the code, I have a node class which will contain all the properties that the node should have, such as the node's ID, which depth it is at, the position of it in the world map, the type of encounter, and the random event that it is, if it's accessible or not, and the list of enemy that it has. It also contains the methods to add enemy and the enum of like the different. So I have a graph class here, and it contains all the methods and variables that are needed to generate a graph with. And firstly, it has an adjacency list, which is a list to represent the relationship between the nodes. So it takes in a node ID, which is an integer, and it takes in a list of nodes that it is connected to as the value. Next, I have a list of all the nodes in this graph, and I also have a node count to assign the appropriate ID of this node to. Uh, the variables here are used for visual debugging, so I can see what is being deleted or not. So next is what happens when the graph is being instantiated. It will create a new adjacency list, and it will also create a new edge list here. Next is the add node method, which it simply adds a node into the node list. It also adds the node into the adjacency list, as well as the edge list, and it will +1 to the node count. This is the add edge method. It takes in source ID and the node target. So source ID is the current node's ID, and the target is the node that this current node is going to be attached to. It goes through a if statement to check if both the source and targets are already existing in the current adjacency list. If both are in the adjacency list, right, it means that both are valid nodes to be connected to each other. And next, it just simply adds in the node to the appropriate key, which is the source ID. So next here is the remove node. It just goes through the adjacency list, and it will go through each key and check the value, which is a list of nodes, and it will remove itself from all these lists. And then next, it will go through the adjacency list to check for its own ID, and it will remove itself from the adjacency list. It also remove itself from the list of nodes for this graph. So next is get connected. It returns a list of nodes, and it takes in the ID of the node that you want to get the list of connections to. So it will check the list adjacency list if it contains the key with this ID, and then it will simply just return the appropriate value that it has, which is already a list of nodes. If there's no nodes is being connected to, it will just return a empty list. And lastly is get nodes in depth. It also returns a list of nodes, and the parameter being passed in is the current depth that you want to get. So for this, it goes through the entire node list, and it will check if the node's depth is equal to the depth that you want, and then it will add it into this nodes in depth list, and it will just return the nodes, the list of nodes that are in this current depth. Next is check for dangling nodes. So it will go through the entire node list again to check if any of the node is if it's any of the nodes are like not connected to node in the next depth, or they are not connected to any nodes in the previous depth. And if it's true, it will just return true, or else it will just return false. This is the map generator class. Firstly, the variables. Depth count is the amount of levels that this map has. Minimum and max node per depth is the minimum and maximum possible amount of nodes that could be generated for each level. The spacing is the distance between each level of the nodes. So one of the variables I use to detect if the nodes can be connected to each other is this max distance for connection. Max distance for connection is the distance like this path. So if the length of this path falls within the set amount of distance, it means the nodes can be connected. So next is the dictionary encounter probability. So my probability manager takes in a dictionary, and within it has the type of encounter and the chances of it. With the higher the float, the higher the chance of this encounter happening. So in the wait function, it will subscribe the methods that it has to the appropriate event. So this is being subscribed to the the event where the map node is clicked. Then after subscribing, it will generate the graph using this method. Next is what happens when the map generator object is destroyed. So it will just unsubscribe all the event that is being subscribed to right now. So in the generate graph method, it will create firstly a new instance of a graph class. It will set a random seed, and from here it will call the method generate nodes and generate edges. And then after generating all the nodes and edges, it will add in a master node, which is the boss node at the end of the map. It goes through a while loop to check the graph if there are any nodes that are not being connected to the next depth or from the previous depth, and it will delete those nodes from the graph, and it will keep checking all those. It will keep going through the graph until it cleans out every single instance of that happening, to make sure that all the paths are available and all the nodes can be accessed from one way or the other. And it will check if there's a minimum amount of like number of nodes in the graph, so to make the game like playable. If it doesn't satisfy the condition, then it will regenerate the graph again until it gets uh, the minimum of amount of nodes. If everything goes correctly, it will just display the graph for the players to see. Next is disable nodes in depth. Is a method that's subscribed to the event where the map node is clicked. So in this method, it will get the node in this current depth that is being clicked, and it will go through each node and make sure that the adjacent node in this depth are all being disabled so that those nodes cannot be clicked again. Next is connected node accessible. Uh, it takes in the node that you click on, and it will check it. It will check the nodes that it is connected to and make them accessible for the user to click. So next is the get random encounter. It goes through a if else statement where if the current depth is 7 below, I want it to not produce any elite before the 7 depth. So it goes through a while loop, which uses my probability manager to select items with weighted probability in it, and it will check if the encounter that was selected, right, if it's a elite, and if it's a elite, it will go through the while loop again to select a new item from the list, and it will select until it satisfies the condition of it not being an elite, and it will return here. It will set the boolean to false to break out the while loop, and then after the 7th depth, it will just go back to normal and just select a random encounter from the list of encounters that I have. So next is the assign enemies method. Firstly, it will generate a random number from 1 to 3. Then it will check if the encounter is a enemy encounter, and then it will add in the amount of enemies that is generated above. So players can face up to 1 to 3 enemies, and here it will generate a random index to get a random enemy from the list of enemy that I have, and it will use the node class method add enemy to add the enemy into the node's enemy list. If the encounter is a elite, it will do the same thing with the list of elite enemies. So it will generate a random index, and it will add the enemy of random elite enemy into the node's list of enemy. But if the node is a boss, it will just add the boss into the node's list of enemies. So the next one is assign random event. It will check the encounter type to make sure that it is a random event encounter, and next it will get the total amount of items in that enum, and it will generate a random index from 0 to the maximum to the total number of item in the enum, and then next from here it will retrieve the actual like enum value of this random event using the index that it generated, and then it will set the node's event into this random event. So I couldn't really figure out how to get enum to act like a list, so I got ChatGPT to generate this for me. I think it's kind of messy, and I wish I had a better way of doing this. Yeah, so next time I'll make sure to figure out if there's any alternative method than this method that I currently have. So this is the add master node method. It is a method which is being used to add the boss node, which is located at the highest point of the map, at the end of the map. All the preceding nodes, which are the nodes from the previous depth, will be connected to this boss node. So firstly, it takes in all the nodes from the previous depth here, and it sets the position of it to the center of the map in the x-axis, and it will space itself out from the it will space itself above the nodes in the previous depth. So here it assigns the node ID, and it creates an instance of the node class. And here it is assigning the different type of properties of this node. Assign enemies. So this will call. It'll go through the if else statement, and it will add the boss enemy into this node. And finally, it will add this node into the list of nodes in the graph class. And then it will go through a for loop to connect all the nodes in the previous depth to this boss node. So this is the generate nodes method. So it has an outer for loop, which is the amount of depth that this graph has, and in each iteration of this outer for loop, it will generate a random number between the minimum node per depth and the maximum node per depth. So this random number is the amount of nodes that are going to be in this current depth of in this iteration. So in the inner for loop, right, it will generate the nodes in this depth. In this inner for loop, it will go for each iteration. It will determine the position of the nodes. It will also get all the node properties that are going to be assigned to this node. So like it will get the current depth of this, it will get the position of this node, and it will assign the node ID to this current node. So if the node is at the start of the map, which will be at the node depth 0, which is here, node depth 0 would always be an enemy encounter. So yeah, if else statement will make sure that. And if the node is 14, which is the node preceding the boss, right here, I made sure that it's a rest site, so the players can heal up right before the boss. So anywhere in between, it will just get a random encounter assigned to it, and then it will also assign the enemies and the random event associated with the nodes. And then after that, it will add the graph. It will add the node into the graph. So next is the generate edges method. It has a for loop in which it will iterate through all the different depth, and in each iteration, it will get the nodes in this current depth and the nodes in the next depth. And then it will go through a for loop again to iterate through a source node, the list of nodes in the current depth. And then within that for loop, it will check through all the nodes in the current depth. It will get the distance of the distance in between the current node and the nodes in the next depth, and check to see if the distance lies within the maximum distance that it can be connected to. So not only that, there's a random chance of the nodes being connected to each other to make it to make the connection of the nodes like more random up. So here it'll create a new instance of the edge class, and uh, here it'll add the properties of the edges accordingly. And here add edge method, in which it will add the information of the relationship between the source node and the targeted node into the adjacency list to represent the path that the players can take. So next is display graph. It's a simple method where it goes through a for loop, taking in the graph, the list of nodes in the current graph, and it will just display the nodes and the associated path that it has. So next is the display nodes method. In this method, firstly, it will instantiate a node game object using the node prefab, and it will position itself accordingly to the node position assigned. And then it will set its parent into the container that I have, which is tagged with the tag graph. Then it will set the game object's name to node, and then the corresponding node ID that it has. It will also set the color of the node game object into this grayed out transparent color to indicate that the node is inaccessible. And then from here, it will set the node object class. It will set the sprite, and then it will make the depth. It will make the depth at node 0 at depth 0, the starting point. It will make all the nodes in that depth accessible. Then next is a display line. So it will get the source node. It will pass in the source node, and then it will get all the nodes that this source node is connected to. So from here, it will instantiate a line prefab that I have at the corresponding like line position, and then using vector tree array, I'll have a source position, the source node's position, and the targeted node's position. Then using the line renderer component, I can set the position of the path of the line, so the start and the end of the line. It will also set the parent of this line object into the container for my map, which are tagged with the graph tagger. And then it will set the line renderer color to the disabled color. Yeah. So next is the method check if node is connected. It returns a boolean, and it takes in a node as its parameter. Firstly, it has a list of nodes that this current node is being attached to, and it has the list of nodes in the previous step. It goes through a for loop to check all the nodes in the previous step, and it checks through to see if this node has any connection to the preceding nodes that it has. Then if there's any connection, it will set the boolean connected here to true. So then it will go through a if else statement. Here, if the node is connected, if the node is not connected, and the node depth is not 0. The node depth is not 0 is because nodes in depth 0 are the starting point, and there will be nothing from the previous depth or the starting point to have any nodes to connect to. Then it will check. So next, it will check this condition if node count is if the connected nodes that this current node has is less than 1, and if the node depth is depth count -1. Then if the node depth currently is equal to the depth count, which is going to be the boss node, so this is checking if it is the boss node, then it'll just return true because it's already definitely connected to something. And else, right, it will just return false. And if all the condition is being satisfied, it will just return true here to indicate that the node is actually connected to something. So next is the prune graph method. It creates a list, an empty list right now of nodes to be removed, and it takes in an adjacency list from the adjacency list of the graph. It also gets a array of game object that I have tagged with the node tag. So this method goes through the list of nodes in the graph, and it will check if the node is connected using this method. And if the node is not connected to anything, it will remove the node. It will add it to the list of nodes to be removed. Then from here, it would remove that node from the graph. It will remove the node. It will add it to the list of nodes to be removed. Then from here, it would remove that node from the graph. So this is the event manager class. The event manager is a singleton. So here is trying to make it a singleton here. And I have a dictionary where there's a enum of events and a list of delegates that it has. So here is the constructing the event manager. So here I have a list of possible event, and it's just an enum with all the various event that happens in my game. So in my event manager, I have three main methods, and it's add listener. So firstly, this add listener will check if this event already has exists in the dictionary of events that I have. Then if it doesn't have any, if it doesn't exist in the dictionary, it'll create a new list of delegates, and then it'll add the listener into the list of delegates of this event. Then next is remove listener. So in remove listener, it will check the dictionary if this event currently exists in this dictionary, and it will remove the corresponding listener from this list of delegates. Next method is the trigger event method. So it takes in the event name, and it will check if this event currently exists in the dictionary, and here for each listener inside the list, it will go through a for loop, and it will invoke each of the corresponding delegates that are in the list of delegates. If the event doesn't exist in the dictionary, it will just log out an error that it's not in the list. So my event manager utilizes method overloading, as I only have three main methods: adding, removing, and triggering. Method overloading allows me to use the same name, but pass in different parameters into the same method. So for example here, I have a add listener which takes in an action as its listener. But here, I want my action delegate to take in a parameter. So here I specified that this action takes in one parameter, and down here this action takes in two parameters. I also have it so that here an add listener, it takes in a func instead of action. A func allows me to return a value as during when the event is called. So here, to make sure that the correct trigger event is being triggered, I have a if statement here to check through if the current listener in the list of listener is the same exact type as this action that I specified, and if it's the same, it'll invoke that specific action only, and it goes the same for my func and uh, my action that takes in two parameters. Yeah. So this is my encounter manager. To start off, it has all the variables of like all the battle objects, the rest objects, and the event objects, and it also has like the current encounter that this encounter is right now. So when the script is just it's just called, you'll gather all the objects that I have tagged with the tag battle, and it'll set it to inactive, and also all the rest objects uh, as well, and also the event objects. Then it will subscribe all the uh, methods that it has here into the corresponding event that occurs. Next is the start encounter method. This method takes in a node, and from here it's just a switch case of the node encounter type, and in the case of enemy it will call the start battle method, and then it will trigger the event of the battle starting. For the elite as well, it does the same exact thing, and for the event it will call in the start random event method, and for the rest it will start the rest method, and for the boss it will also trigger the same things as the enemy encounters and the elite encounters. So this is my start random event method. It takes in a node as its parameter, and it will go through a for loop to go through each item in the event object list and set it to active, and then it will trigger the event of the random event being initialized, which is in the random event handler. This is my start rest method. Firstly, you'll go through the for loop of all the rest object array, and then it will set each item in that array to active. Then it will trigger the rest initialize event, and then it will also trigger the main map node click, which would disable all the nodes in the same depth and closes the map as well. Then next is the end rest. It will set all the rest object to inactive to close the event, and then it will also trigger the event of the map node being clicked again to open up the map. So next is my methods to handle starting and ending the battle. Uh, for it goes through a for loop, which is the same as the rest, and it goes through the battle objects, and it'll set all of them to active. Then next, you'll find the enemy, the container that I have for the enemy, and then you'll instantiate the appropriate enemy inside the enemy container that I have, and then it will trigger the event map no click, which is it will close the map. Then for the ending of the battle, it it gets the list of enemies that I have that are currently inside the enemy container, and it'll go through the list and destroy each of the enemy object inside of it, and then it will go through the battle objects and set all of it to inactive to close the battle encounter, and then it will trigger the map no click, and which is for opening up the map again. So this is my enemy class. Here it has all the variables that I need for the enemy to function, and here it starts off by subscribing itself the get intent uh, method to the player turn event, and the check death method to when the player attack finish. So there's a method here, turn start, which is played when at the start of the enemy's turn. So here, if the enemy is shielded, it will set the enemy's defense to 0, and it will make sure that their shield are being reset. Uh, Next, it's all the method to play the various animation I have. So here I have the play attack animation, and it will just play the attack animation for the name attack. And show floating text is it will spawn a floating text to display the amount of damage that is being dealt to the enemy. So right here, it's just this text. Uh, it will spawn the text, and it will change the text to the appropriate like damage that is being dealt to the enemy. And then next is check death. This method checks if the enemy is dead. So here, if the enemy has less than or equal to 0 health, it will set the enemy to be untargetable, and it will set its state to be dead. Then it will play the death animation for the enemy. So from there, it will also check if all the other enemies are dead by calling this event of enemy death. This event is being listened by the check all enemy death method, which is under the battle manager class. Here, it will trigger the event of like enemy death. So if it's like the encounter type of a boss, here, it will change the scene to the victory screen. And then if it's not the boss, it will just trigger a normal like enemy death event, which is to end the battle. Next is the get intent method. So you'll just get a random move from the list of moves that the enemy has, and there's also the perform action, which it will check the current move, what move it is. If it's an attack, it will play out the attack animation, and it also trigger the event of the enemy attacking, which is listened by the player taking damage method. And next is the defense. So it will give the enemy the amount of shield that is like specified under the moves like shield amount. I also had plans to have a debuff and buff move, but I didn't have enough time to implement those. And after performing the action, it will update the HUD to update the player's health and the enemies like defenses accordingly. So here, it's a take damage method. It takes in the damage type class as one of its parameter, and firstly, it will check if the enemy has a shield currently, and if the enemy has a shield, it will calculate the shield damage, and if any of like if the damage that is currently being dealt exceeds the amount of damage the shield can take, it will get all the outstanding damage that from the shield, and it will reduce the health of the enemy accordingly, and it will set the state of the damage calculation to be true. If the enemy is not shielded, then it will just start a coroutine, which is to calculate the health damage that is being taken by the enemy. Next is the calculate shield damage. Here, the enemy will there's a variable for of outstanding damage, and it will go through the total number of hits, and it will reduce the shield, and any outstanding damage that comes from reducing the shield will be added into the outstanding damage total. And if there's any outstanding damage, it will just return the appropriate amount, and if there isn't any, it will just return 0. This is the reduce shield method. Firstly, it calculates the outstanding damage that the player has by taking the damage taken and subtracting the current defense from it. And then it calculates the current defense of the enemy. So it will take the current defense and it will subtract the damage taken from it. And if the current defense is like less than 0, it will set the shield to false, and it will return the outstanding damage that is supposed to be handled by the calculate health damage area. Next is the calculate health damage coroutine. Here it will go through the number of hits, and then it will reduce the health in each iteration by the damage per hit. It adds an artificial delay so that the floating text that appears wouldn't stack together, and the sound effects wouldn't stack together as well. And after this is done, it will return true it will set the state of it being done to true. Next is the reduce health method. So it takes in a float of damage taken, and it will calculate the current HP that the enemy has remaining, and then for each like damage instance, it will spawn in a floating text to show the amount of damage taken by the enemy. And next is the damage calculation. It's damage calculation done method. It will just return if the damage is finished calculating before the enemies can end their turn. So I decided to consolidate all the different types of move that the enemy can have into a move class. So it's differentiated by the different type of actions they can take. So there's a attack, defend, debuff, and buff. And here are the variables to make the move happen. So for example, here this is the constructor, and it will take in the appropriate parameters and assign it to the correct variables that I have here. So an example of the move class being used is under the Giant Slam move, which is the boss that we have in the game. So it has a dictionary of the varying moveset with the move and the float. This will be used in the probability manager to select a random move out of the move pool. So here, for example, move 1, it constructs a move with the attack type and the corresponding damage per hit and the number of hits. Same thing goes for the second move, and in the third move is the defend attack type, the defend move type, where it does 0 damage, it does 0 hits, but it provides the shield value to the enemy. Here is the moveset dictionary, where the key of the dictionary is the move, and the value of the dictionary is the weighted like chance that they have of that move happening. So for the enemy script, it is attached to the enemy various enemy prefabs with like the max HP set here and the different sources for its like sound effects. Here, example here is the boss giant slime, and the giant slime have its like giant slime moves like attached to it. I could give another example here, which is the Cerberus, and yeah, it also has a enemy script and a Cerberus move attached to it with its like various audio sources and stuff. So next, this is my player class. This player class is attached to the player game object, which is here, right here. So in the player class, there's a bunch of variables that determines the various properties of the player. So they have the max health, the number of dice they roll per turn, their current HP, their current defense, and the base value of their defense here. They also have their state if they are shielded or not, and also they have like the base damage and the base number of hits of of the player. They also have like their max number of energy here. So when the script is just initialized, it will set the player's current HP to the max health that the player has, and it will also set the defense value to the base value of the player. It will get the animator component, and it will also give the player it'll set the player's like damage type to its base settings. It will also subscribe the various like methods that this player class has into to the events corresponding to it. Then on it being destroyed, it will remove all the events. It will unsubscribe itself from all the events that is happening. So this is the heal method. It takes in the amount to be healed as one of its parameters, and it simply just adds the amount to be healed into the current HP. And in the case where the current HP exceeds the max HP that the player can have, it will just set the current HP into the max HP. Next is the method for defending. This method sets this player's state to be shielded, and it also sets the current defense of the player to the current defense value that it has. And then after setting it, it will reset the value of the current defense, and it will reset it to the base defense value. Next is the method to reduce the amount of energy the player has. So as long as the energy is not at 0, it will just minus the energy cost that the player's action is taking. So here are the various checks that happens during the gameplay. Firstly, it will check if the player has enough energy to do the action that the player wants, and it will just return a boolean, true or false, if the player has enough energy or not. Next is check player death. Here, it will check if the player's current HP is less than or equal to 0, and it will play the appropriate death animation for the player, and then it will return the true or false value. So here is the methods to play the attack and defend animation, and then here the show floating text is when it's similar to the ones that the enemy has, where it just instantiates a floating text prefab, and it will change the text to the appropriate damage that the player is taking. And here it also instantiates a slash effect prefab, and it will play the animation of the slash effect. So next is the take damage method. The method that the player class has is similar to the one that the enemy class has. So here, instead, there's an additional line added to play the animation of the player blocking the attack, and it also has the additional animation of the player getting damaged. And then it will update the HUD also to reflect the current player's health and shield. It will also check if the player is dead, and if the player is dead, it will load the scene, the death scene. So here are all the methods responsible in modifying the various variables of the player. Firstly, here I have modified damage, which is being used by the enhancement system to increase the number of hits of the damage type, and the number of damage per hit of that specific damage type. And I also have modified defense, where it takes in the modifier amount and it just adds the modifier amount to the current defense value that the player has. Upgrade defense is being used by the rest side and the random event encounters. It adds like amount that an amount that's passed in into the base defense value. Same thing goes for the upgrade damage where it increases the base damage and also the number of hits here. And also the increased max health function takes in the amount of health to add, and here if the current HP is like more than max HP, it will set the current HP to the same as the max HP. Yeah. Also have methods to increase the max energy that the player can have and increase the max number of dice that the player can have. So these are like the turn actions. On turn start, it will reset the current energy the player has into his max energy, and if the player is shielded, it will set the defense to 0 and reset the state of the player to not shielded. I also have a method to reset the damage value to the base damage that the player has and the base number of hits that the player has. So this is my attack action class where on the press of the button, it will instantiate an arrow prefab which contains this arrow head and arrow body, and this, yep. And then when the player releases the mouse, it will check if the player has enough energy to attempt that action. And if the player has enough energy and the arrow object is not now, and the target there is a target selected currently, then it will use that target and perform the attack action onto that target, and then it will destroy the arrow object afterwards. If it doesn't satisfy any other condition, then it will just play the denied sound effect and destroy the arrow object as well. Here I have a on drag. The on drag is just it updates the position of the arrow to where the mouse is currently. And next is a coroutine or perform attack action. It will trigger the event of the player attacking, and the specific target that was selected will take the amount of damage that the player deals. And then it will reduce the energy cost. It will reduce the energy of the player, and it will play the attack animation for the player by triggering all these events. Then it will wait until the enemy's like damage calculation done, and then it will trigger the event where the player attack is finished. Here's the spawn arrow method. It gets the current position of my mouse and it will spawn the arrow corresponding to my mouse location here. So the defend action is on click of the button, it will trigger the player defend, and it will check if the player has enough energy to do this action. And if the player has enough energy, it will give the player the shield and play the animation accordingly. And it also reduce the player energy by the energy cost of this action. Then it will play the sound effects and it will update the HUD when the player defend has finished. Then if the player doesn't have enough energy, it will play the denied sound effects. Next is the material action. Material action here has a dictionary of like all the materials, with the key being the material name and the value being the amount of materials the player has. Here it subscribes to get material list, finish dice roll, and the reset material counter is corresponding events. And on pointer down, it will spawn a prefab of like the icon of the material, and like when the player drags the material around, it will update the position to follow where the players like mouse are. So on release of the mouse, it will check if the player has enough energy to enhance their actions. and then it will check if the material object is null to make sure there is an object there. And here it will get the action object that the player released the mouse on, and then from here it will do its corresponding action. So if the action is a attack action, uh, it will enhance the attack by the materials like damage modifier and materials like number of hits. Then if it's successfully in enhancing the attack, it will reduce the energies. It will reduce the player's energy. Then same thing goes for defend, where uh, when the tag is like the defend tag of the targeted action, it will increase the player's defend by that defense modifier, and on successful enhancement, it will reduce the player's energy cost. Then it will play the sound effect, and then it will take away the count of that material that the players has used. And then when the event is successful, it will trigger the update for the HUD, and then it will destroy the material object instance that was spawned in. So here there's the reduced material count, so it will just get the key of this material's name, and then it will just -1 from that list, and then it will update the UI accordingly. And then on finish dice roll, it will update the material list to show the amount of materials was added, and it will delay the destruction of the dice box. Here the delay is to show the players the results, and then after that it will trigger the event to destroy the box. So under the material prefab class, on the spawning of the class or the game object, it will set the appropriate sprite to the corresponding materials icon, and then on update position, it will just update the position of the game object following the mouse of the player. And then when it collides with one of the hitboxes of the attack or defend action, it will update the collider object variable to the corresponding game object it collided with. And then on exit, it will just set it to null. Next is the get action, so it will get the corresponding collider objects action, and here is the set sprite. So yeah, it will set the sprite accordingly to the icon that the player clicked on. So when the player's turn start, it will instantiate a box, and this dice handler script is attached to that box. So when the box is spawned, it will spawn dice according to the number of dice that the player has, and with that it will go through a for loop, and it will instantiate a dice prefab under this spawn position that I have set, and it will add that dice into the dice list that I have. So I have a method here to check if all the dice are stationary. I have an integer, which is the counter for the amount of dice that are stationary at this check. Then it will go through a for loop through the list of dice, and it will check if each dice has landed. Then it will add its counter +1 to the total confirmed dice that is stationary. Then if the confirmed number is the same as the number of dice that was rolled, it will return true to show that all the dice are stationary. So next is the update material list. Firstly, it will get the material list that I have inside my material action class, and then it will go through the dice list, and for each of the materials in the material list, it will add that specific dice material it has to the counter of the material list. Then it will trigger the event of like ending the dice that is also under material action to method of finish dice roll. And then lastly, I just have a method to destroy this box that I have, so it will just destroy this game. So this is my dice script that is attached to my dice prefab here, and at this instance where this dice is spawned, it will set a random state for the dice. For setting the random state, it will reset the current roll time of the dice to 0, and it will add a random force to the dice. So here, to add a random force, firstly, I set the dice at an initial spawn point by changing its position, and then here I'll add a random rotation to the dice, so they'll be rotated randomly, and I'll also have a random force here in like all the varying axes, and the varying amount of like torque, random torque to add to the dice. And here I would set the dice to the corresponding like rotation, and I'll set the velocity of the dice to the force that it has that was generated here. Then I'll increase the maximum angular velocity of the dice so that the dice can spin fast and it will look like nicer. I also added torque to the dice to increase the amount of rotation the dice has. Next is the method to check if the dice has stopped. It will check if the rigid body's like velocity, the magnitude of the velocity is less than this amount, and if the angular velocity is like less than 0.1 float, then it will return true or false accordingly. It's not exactly at 0 because there are very minute like movements on the dice, so it will take a long while for the dice to actually reach a point where all the magnitudes are 0. So I just set it to the amount where it will look like the dice has come to complete stop, and the dice are not like actually moving, and even if it is moving, it wouldn't affect the outcome at all. So I have a find phase result method in which the method will go through all the children in the dice hierarchy, which are the varying detectors I have on each faces of the dice, and it will check if the position of this current dice is higher than the position of this iteration of the dice, and if this iteration of the dice is higher than like the current highest one, it will set the current highest detector to this iteration's detector. Then finishing the for loop, it will return the index of this current like phase detector. So I have this method here just updates the texture to show that, like, to make it look like the dust is lit up, and to show that it's currently like face up and not moving anymore. And I also have a method to have the sound effects. This is played when the dust is rolling on at the start, and this effect is played when the dice is collided with something.